Good morning, everyone. We can just wait for a few more seconds. The participants are still joining. Let them join, then we will continue with the lecture. Thank you. Okay, so good morning, everyone. We are having a lecture today for PEPE, the Pharmacoeconomics and Pharmacoepidemiology subject. So in this subject, I have two lectures actually, that is data presentation and data summary. Actually, the topic is data presentation and its limitation is mentioned in the syllabus. But I will divide this lecture into two lectures as per the syllabus. So today I will explain about the data summary and data presentation, the basic components of this lecture. Then by the next lecture, by tomorrow, we will cover the remaining portion, including the limitation of the data as well. So let's start from the today's one. So subtopics belongs to this topic is actually the definition of data. We will discuss about the definition of data and its basic components. Then the data variable, types of data variables, we will discuss different variables of the data we will discuss. And then we will discuss about the various data presentation tools. Various data presentation tools, we are having a different presentation tools. So how we can present our data, that also we will discuss by today. And then the topic learning outcome. At the end of the lecture, you will be able to explain the definitions of data and its basic components. Then at the end of the lecture, you will be able to explain the type of data and variables, what are the variables are and what are the types of variables are having. You will be able to explain that at the end of lecture. And the next topic learning outcome will be the describe various data presentation tools. So you will be able to describe the different data presentation tools. So let's start from the first one is actually what is definitions of the basic component. First of all, what is data? Data is actually defined as the observations such as measurements, gender, survey response that have been collected. So this is actually the data. So how we explain is data is actually when we do some research. Basically, when we do some research, maybe the research can be clinical oriented, it can be survey based, it can be hospital based, or it can be non-clinical, it can be laboratory based. So whatever the raw component, whatever the outcome from that research, once we give the things to the once we handed over the questionnaire, if our research is if our research is questionnaire or survey based, we will hand over the questionnaire to the participant first. The participant will give their response back to us. Then at the end, we will have data in our hand. From that data, we will make the results of the data and all. So this is called as the data. This is actually, it can be measurement, it can be gender survey, it can be like how many people were involved, how many males were involved, how many females were involved, and how many of them are the Malay, how many of them are the Chinese, how many of them are the race Indians, so different race as well. So this is called as the data. Second definition is statistics. Statistics is actually the collection of method for planning experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusion based on the data. So statistics is actually some of the softwares we are using these days, statistical softwares. But actually the statistics is actually we need to calculate the result of the data. Let's say we have taken the response from the 100 participants, the response was there. From that response, maybe two questions we asked, some of them was the direct question, maybe knowledge based question. We want to see what is the knowledge, how the knowledge of the respondent is, whether it's good knowledge or not good knowledge, or maybe how many participant has responded correct answers, how many participant has responded wrong answers. So at the end we want to calculate. How we will calculate? With the using of statistic. Similarly, the example is, if let's say we have measured the blood pressure of 20 people blood pressure we measure, so later we will calculate the mean. How we will calculate the mean is called as statistical method. Statistical method mean that we will calculate the mean. We can sum all the numbers together, then we can divide on the numbers, we will calculate the mean. If we can do this thing by using of Excel, Microsoft Excel, we can use this as by using SPSS, we can use this as to do the things by using our software. So different softwares we are having these days to make the statistical analysis. The statistical analysis is actually nowadays our life is very easy because of the computerized software. We just put our data into the software, we apply statistical analysis, then we will get the results. Okay. Next is population. Population is the total overall overall community on where you are going to do the research. The exact definition is the complete collection of all elements, score, people, measurement, and so on to be studied. The collection is complete. The collection is complete in the sense that it is included all subjects to be studied. So mean that the population, let's say we want to do the research on a student population. So all the students in that university are the population, but maybe our sample size is those respondents who want to do the response, those students who want to do the response. Sorry, that is our participants. But the population, when we consider population, overall whole community of student is our population. But from them, whoever gave the consent form, we will include them. Those who have not given the consent form, we can exclude them. This is different thing. But overall, when we talk about the population, so all people involved, all people having the same statistic, which can be our sample, is considered as a population. Then the second thing is goes to the sample. What is sample? Sample is actually sub collection of element drawn from the population. So mean that from the population we have selected few things, few people, that is considered as our sample. This now I have explained. If let's say we want to do a study in any university, all the student participants, all the students involved in this study, all the students belongs to that university, and whoever are the under that university, they are the population of that study. But we want to do the research on healthcare student, then maybe pharmacy, medical, dental, and these all can be our sample. But overall, when we consider that the student population was a sample, the population student was the population, then all students are the population. If our study is focused on the managerial kind of study, then maybe our population is only the management school, the school of management, only that student. But when we consider the population, whole university students are our population as well. Then the next one is a researcher. For example, the example is there, a researcher want to study the effect of smoking on cholesterol in country. If let's say one researcher wanted to do the research to find out the effect of smoking on cholesterol in country, so how he will do? What would be his population? Who are the participants? Who are the population of this researcher? Researcher want to do the effect of smoking on cholesterol in country. So mean that all the smokers are the population of this study, and all adults in country who smokes at least 1 pack per day. So mean that all the smokers can be the population. The next question is, what could possible be his sample? Then some reasonable number of smokers in country who smokes 1 pack per day. So the sample size, when we consider a specified sample size, then it is further actually filtering from the population. So population is the overall community. Overall community in this example, when we consider the overall community, all the smokers are the population of this study. But when we consider that the possible side effect of cholesterol, then maybe we need the population of the smokers who are smoking, and also who are giving who are having a cholesterol level with them. If the cholesterol level is there, If the cholesterol level is there, then it is easy for us who are regularly checking their cholesterol level, then should be enough to study. So then we can further, if the similar kind of thing, the all the smokers, if we want to include, we cannot include all together, we have to pick some of them, that is called as our sample. Some of people only we will include, not everybody. Not, if we consider the smoking effect throughout the country, want to see, it's not possible for us to consider everything, everyone is not possible. Then we have to say, take few of them, that is considered as our sample. Then what is statistics? Statistics is the science of collecting, describing, and interpreting the data. Just now we have explained. Two areas of statistics are further there. That is can be descriptive statistics and inferential statistics. Descriptive statistics is actually the collection, presentation, and description of sample data. So descriptive, from the name itself indicate, descriptive means the description only. Description only. When we consider description only, if let's say we want to say that in pharmacy, how many students are there? So we overall we say that 360 students are there in faculty of pharmacy in AIMS University. Okay, that is descriptive statistics. But when we go to inferential, then we need to tell them how many are them from final year, how many are them from year 3, how many are them from year 2, and how many of them are from year 1. And then if we further go inferential statistic, then we need to explain them how many year 4 students are already have A grades, how many year 4 students are having a B grade, C grade, and all. Then similarly goes to year 3, year 2, and year 1. So descriptive statistics mean that the only description, mean that the basic description when we give the data, only basic description when we give is called as descriptive statistical analysis. If we consider that inferential statistic, inferential means further we need to highlight. That is what the example just now I have given. The further, if we study further from the total population, we are saying that how many pharmacy students are there. We just say 360 are there, total 360 students are there in AIMS University for pharmacy student. Okay, this is descriptive. But when we go to inferential, then we need to tell them further how many are from year 2, how many are from year 4, how many year 3, year 1, and all. And then similarly further description, further inferential statistics we can apply. We can tell them how many are having A grade, how many are having B grade, how many are them from them are in the dean's list and all. So this is considered as the inferential statistics. This is the example of descriptive statistics. This is the one of the previous study table I have taken from my own study. So now you see in this table we can see the age, how many are less than 20. In the 40 people was in this study, 40 people was from the less than who was having age less than 20 years, and they are 15%. And then from 21 to 30, they are 193 in number, and the percentage is 72.3. And then similarly for 31 to 40, then more than 40 this is long. Then consider as the gender, male, how many males involved in this study was 86, and the percentage is 32.2%. If we consider the females, how many females involved in this study, 181 females was there, and the percentage was 67.8. Similarly for urban and rural area, similarly for monthly income, and then education level. So this is considered as the descriptive statistics. In this analysis, we only give n percentage. This is considered called as n percentage of data description. So n percentage, only number and their percentage we have given. Only few detail we have given. If let's say we have given that how many males, this many males, this many females, but we have not given that how many males in this study who have participated from this 86, how many from this 86, how many students have good knowledge, how many student has got not good knowledge, how many student of this 86 are having A grade, how many having a B grade, and all. We have not stated that. This is considered as the descriptive statistical analysis and presentation of data. Then goes to the next one. This is considered as inferential statistics. This is actually the cross tabulation. We have applied some of the statistical analysis. This statistical analysis we applied is the person's chi-square analysis we have performed. chi-square or the Fisher exact test we have performed over here, and the effect size also we have tried to calculate. So when we consider that how many are males are having less knowledge, means less good knowledge, they are seven in number, and 8.1% of the students are having less good knowledge. And moderate good knowledge are males whoever having a number is 26 and the percentage is 30.6. How many are high knowledge? High mean the very good knowledge, they are 61.6%. Similarly, it goes to female, and then 3.3% is having a less good knowledge. Then the moderate knowledge is 33.7%. So this is considered as a statistic. But when we consider the p-value here, it tells us that whether there is any kind of effect of gender on knowledge or not. This p-value is non-significant. This p-value you can see is non-significant. It is more than 0.05. So mean that there is no relation of knowledge with gender. Male also can have good knowledge or female also can have good knowledge. If you see the percentage, it is almost similar. Now you see the females and male moderate knowledge, this here is 30, here is 33.5, 33.7%. If the 0.05 means 5% of the whole population, 5% of whole population, if different, then only we can say that the knowledge is different. But in this case, we cannot see the 5% difference in all the statistics, all the portions. So mean that the p-value is non-significant. If p-value is non-significant, there is no effect of any gender on knowledge. Mean that male also can have good knowledge, female also can have good knowledge. No effect of gender on knowledge. But if in the same study we have studied that year 4 and year 3, or maybe year 4 and year 1 student knowledge, then the p-value can be significant. Why? Because maybe year 4 student are having very good knowledge, but year 1 student, they don't have that much good knowledge because they are just now registered. They don't have the knowledge of the field. Then they will not have a p-value non-significant. Here the p-value will be significant. Significant value will be there. That is, so this is all about the inferential statistics. Then types of data types, actually there are two basic types of data. First is the qualitative data, then the second one is the quantitative data. When we talk about the qualitative data, so definitely we are meaning over here, qualitative data means we are talking about the quality. Quality is actually categorical data. So when we are saying that the quality, we are saying that okay, the quality is good or not good. So we have two options. in the qualitative data. Quality from the name indicates, qualitative data mean the quality. Quality can be further categorized. It can be good quality, it can be moderate quality, it can be bad quality. Mean that the categories are there of the quality. So those data who can be categorized further is called as a categorical data, or is called as a qualitative data. So in the qualitative data, the example is eye colors. Eye color can be black, it can be yellow due to jaundice, it can be red sometime, or if infection is there, it can be bluish sometime. So eye color can be the qualitative data. Ice cream flavors, we only have few flavors, that also are qualitative data. Car models, and then the rating, movie rating, good or bad. Then the pain scale mean sometimes we ask from the patient, you have a pain, how much the pain is there, you have a very strong pain or not strong pain. Mean that sometimes we are having from zero to we are having a scale from 0 to 10. So we ask the respondent to respond accordingly. Sometimes they can respond that their pain is moderate pain. Sometimes they said the pain is low pain, less than very severe. So it can be qualitative, it can be categories. This is considered as a categorical data. Further examples, it can be when we study the population, when we study the student population, or something we want to study that the blood pressure control, whether the blood pressure is having control or not in the population, yes or no, then it is called as a qualitative data. Similarly, when we consider the blood pressure, blood glucose level, whether the glucose level is controlled or not controlled, yes or no, that can also be. Sometimes we study that the knowledge is good or not good, it can be qualitative data. So qualitative data can be further classified into categories. Few categories are there. So sometimes further classified, it can be further classified in called as the qualitative data. But then the second type is the quantitative data. Quantitative, is the name indicate, is usually represent the quantity. Quantity can be in numbers, maybe 1, 2, 3 or 7, sometime 9, 10, 11, or sometime it can be for like we can say that the blood pressure of the patient mean blood pressure of the patient was 135 systolic and 82 diastolic. So this can be qualitative, this can be quantitative, but because it is quantity, it is in numbers. Similarly, for the blood glucose level, we can say that 6.2 millimole per liter in fasting. It is a quantity, it is a quality, quantity. The numbers, when we talk about the quantitative, numbers should be there. If numbers are there, this is considered as the numerical data, nominal data. So nominal data can be in the numbers. It can be full numbers, or it can be with the decimal point. So further we can study that the examples. Classify each of the following set of the data can be either qualitative or quantitative. Measures of anti-diabetic drugs. Anti-diabetic name. If we want to study the name of the anti-diabetic drugs, we know that only few drugs are available. So mean that the classification of anti-diabetic drugs we are talking about here. So we know only few classes are there. Classification is there. If classification is there, then this data is called as a categorical data. Categorical data is a qualitative data. Then the second one is the score on a multiple choice question. If let's say you have a 20 marks multiple choice question, how many of you are having 18 marks, how many are having 15 marks, how many are having 10 marks? This is a numbers. This is a number. So this data will consider as a numerical data, or this data is considered as a quantitative data because it is a quantity in numbers. So it is considered as a quantitative data. Now you know that in clinical research, if we want to study the blood glucose level, then it is considered as a quantitative data. When we study whether the blood glucose level is controlled or not controlled, mean the classification is there, then this study is considered as a qualitative data. If quality is there, good, bad, yes, no, control, not control, this is considered as a qualitative data. Mean the categories are there. If categorization can be done, then it is called as a qualitative data. In quantitative, the numbers will be there, whether blood glucose level is 6.2, blood glucose level 4.2, whether blood glucose level is 7.8, whatever the number is. If number, then it is a quantitative data. Quantity is there. Then control of hypertension in patient population. What kind of data is it? Control of hypertension. It is controlled or not controlled. It's considered as a qualitative data. Qualitative data, control or uncontrolled. Similarly, cost of treatment. Cost of treatment, definitely we are having in numbers. In number, let's say we are saying that 120 or maybe 280, something like that. Then the amount, the number will be there. If number is there, cost of treatment, if number is there, then the data will be considered as a quantitative data. Quantitative data, quantity is there. So if any quantity, any number is there, is considered as quantitative. If any categorization is there, classification is there, then it is considered as a classification of the data, is considered as a qualitative data. Good quality, bad quality, remember from the name itself. Then the further definition, the qualitative data or categorical data. Categorical data can be separated into different categories. Just now we have studied into different categories. It can be further different categories can be involved that are distinguished by some numerical characteristics like gender. How many males are there, how many females are there of one study. Similarly, if we talk about the race of the study, then it can be in Malaysia, it can be Malay community, it can be Chinese community, it can be Indian community, it can be others. This can be the one thing. Then the other thing is another example is blood glucose level, control, not control. Blood pressure of the patient, control, not control. So this is called as a qualitative data. Quality is there, categorization is there. Then working with a quantitative data. Second one is the quantitative data. Quantitative data can be like just now I explained, the numbers will be there, the quantity will be there. If hypertension 137 by 80, this is quantitative, or 6.2 millimole per liter blood glucose level, this is a quantity. So quantity will be there, the numbers will be there. The numbers can be discrete or continuous. It can be discrete, continuous. Let's say we talk about the data and the possible numbers will be there. Let's say we are saying that how many people, how many students are from living in hostel. The hostel student will be like 47 or maybe 80 out of 100, or maybe we can say that 70. We cannot say 70.8 students are living. No, this is the whole number we want to say. We want to say the whole number. So numbers can be the total number. It is total number. It can be discrete variable, and then continuous mean it can be fall anywhere, like from 2 to 3. It can fall here, it can be fall here, it can be fall here, it can be fall here. So the example is the cow milk production. It can be 2.343115 gallons per day. It can be, or we can say that the blood pressure of the patient was, the mean blood pressure of the patient was 137.82 diastolic and 82.37 in the is diastolic, systolic and diastolic. So 132.23 is systolic, or maybe 82.62 is a diastolic, something like that. Similarly, for the blood glucose level, 6.2, or cholesterol level, we can say that it can be 6.9, it can be 11.2. So mean that the number will be there, but after the decimal point, some amount is also there. If we consider the HbA1c of the blood glucose level, we know that the blood normal is 6.5%. If let's say it is increased, it became 7.0, 7.2, it is high. Or if it became 6.9, it is also high. 0.4 is high. So then mean that the after point also numbers also vary. Number also have a value. If let's say you're saying that the patient, the normal blood glucose level, HbA1c should be 6.5, but if your patient is having 6.9, 6.8, it is little bit high. You have to get further control. If you are saying that 6.2, 6.3, mean that it is less than 6.5, still it is okay to receive this amount, something like that. So mean that after decimal point there should be number, and that number also have value. This is called as a continuous data. So mean that in when we talk about the quantitative data, it can be further classified into discrete and continuous type. Discrete type is the total number will be there. For example is already given here, and the other example is total number of students living in hostel. Maybe 32, maybe 82, maybe 130, something like that. Total number will be there. And then if we consider that the further second type, then it is considered as a continuous. Continuous can be after decimal point, some number will be there, like 3.2, 2.8, 3.9, something like that. So this is called as a continuous. Then the types of variables can be categorical variable or numerical variable. There are two types of variables. They can be numerical, they can be categorical. Numerical is when the data is in a numerical form. Numerical means the data will be in a quantitative. Then categorical variable, the data can be categories. If we enter the data into SPSS, if you have used in your year 3 research project, you know that the numerical data, when we talk about the total mean score of the respondent, that how many they got in the, let's say for example in the final examination, we are saying that to, how many mean score of question number 3 of the student, maybe they can be 3.9 out of 5 is considered as a numerical data. But when we consider pass or fail, then in the whole paper we can say that maybe 92% of the respondent was passed in the paper and the remaining 8 was failed. This is considered as a categorical variables. So when we enter the data into SPSS, over there we need to select the variables. So sometimes if let's say your variable is a gender, you know that it is categorical variable. If your variable is a race, you know that it is categorical variable. If your variable is a temperature of the student, these days we are maintaining the temperature of the student, we are checking the temperature can be 36.2, 39.3, 39.8, very high, something like that. So the data, the number will be there. If numbers is there, then we will measure that data. We will categorize that data as a numerical data, categorical data and numerical data. Then the summary is actually the data can be classified into quantitative, into qualitative and quantitative. Qualitative data, we know that the qualitative data is actually the quality which can be classified, and then the quantitative data is the quantity which can be discrete or continuous. If discrete means the whole number will be there, continuous can be 2.3, 3.8, 9.6, something like that. So now this is the overall picture. The qualitative data can be numerical, it can be ordinal. Qualitative data can be numerical and ordinal, and then the quantitative data discrete or continuous. Then further interval and ratio will be there. Interval ratio will be there. Then the data presentation, the second topic is data presentation. Data we can present in different ways. Sometime in our research, when we want to publish that research, we can present that data into a table form. We can present the data into the graph form. We can present the data into different methods are there. Sometime if we want to put a descriptive analysis, then n percentage is enough to put. But sometimes we want to present the data into further explanation can be given. Then the data can be presented into table, but we need to calculate the p-value, effect size, or sometime we want to calculate the regression analysis. We want to put the interquartile range. Then we want to calculate the 95% confidential interval and all. This is considered as inferential statistics. So now we talk about the various data presentation tool. First of all, it can be tables. Tables we have already explained. I have given the examples just now for the tables. Table can be very simple table, or sometimes it can be complex table. If simple table, it is considered as a basic data, that is descriptive data. If further analysis was done, or further explanation was added, further p-values was calculated, some statistical software was applied, statistical analysis was done, some values was calculated, then it is considered as the inferential statistics. So the first example is the tables. Then the second one can be line graph. The line graph, then the line graph, it can be in the line form. Then the bar graph, it can be bar graph, it can be pie chart, it can be diagrams. And then we further study, like this is the example of a table presentation. If we consider this example is a descriptive analysis, descriptive data table. So first of all, this is the actually stages of CKD. If we consider stage 1, the GFR should be like should be more than 90. This is considered as a GFR stage 1. If stage 2, then the GFR should be from 60 to 89. If stage 3A, then 45 to 59 should be their GFR value. And if 3B, then 30 to 44 should be there. Then if the stage 4 is there, then 15 to 29. If stage 5, then less than 15 GFR should be there, then it is considered as the stage 5. This is a simple example of table presentation, data presentation to the table form. Simple example. This the further inferential. This is a descriptive statistical analysis. And then inferential, I have already given the example. And when few days ago you were presenting the data into your presentations, that the tables was there, 95% confidential interval, and then the table was there for p-value significant. Then the regression analysis was also there, interquartile range was also there. So that was the further statistical analysis considered as the inferential statistical analysis. That was the example of inferential statistics. And then the bar graph. Now you see the bar graph, blood glucose level bar graph. So now you see this one, the minimum was 6, and then at 7 o'clock. Then after that, when we measured the level at 1 o'clock, it was more than 10. When we measured the level at 7 o'clock, then it was around 9 somehow. Then when we measure at 11 o'clock in the midnight, then it is considered as 4.5. This is first thing on Friday. This data was on Friday. Then when we consider the data on Monday, now you see this value. Monday in the 7 o'clock, the level was very high. It was 12. And then after when we measure at 1 o'clock, then it was decreased. it was 6.3 something. And then when we measure the same into at 7 o'clock, it was around 11 somehow. Then when we measure the same at the 11 o'clock in the night, then the value was around 9 point something, 9 point something. So this is the method. By this you simply see that in this table, we have highlighted. If we want to explain in words, it will take many number of paragraphs we have to write, many description we need to give. But simply when we present the data into this graph, then it is very easy and self-explanatory. So now you have presented all the 7 days of week, the data of all 7 days of week blood glucose level with the time interval you have presented in one table, in one graph. Everything is included there. So this is the benefit of data presentation into the graph form. But when we if we want to present the same thing into description, then you have to write many words. Like first of all, you can say that when we measure the blood glucose level on Thursday, at the 7 o'clock, the blood glucose level was 14 point something. Then when we measure the same blood glucose levels on Thursday at 1 o'clock, it was around 16.2 or something. Then when we measure the same at on Thursday, when we measure the blood glucose level of a patient at 7 o'clock, it was around 11 something. So these all statements has to be written only for one day. Similarly, for another day, another statements has to be there. Then the another statement. So all the days of a week we have to present one by one. Then it will require it requires more number of elaboration, more number of statements, more number of words, more paragraphs are needed. So but with the help of a line graph, with the help of a statistical software, with the help of Excel, Microsoft Excel, with the help of R software, or with the help of SPSS, we can just present the data into the graph. Then from the graph, it is self-explanatory. Anyone can understand. It is a scientific kind of writing. Then bar graph. Now you see number of vaccine refusal by state from 2013 to 16. We want to see how many refusal was there. Let's say in 2013 in Perlis, the refusal was around 20 somehow. Then when we talk about in 2014, the refusal was in Kidda, it was very high. It was more than 240 somehow. Then when we talk about this one is the 2016 in Perak, the refusal was 280 something, like 280 something like that. So similarly, when we consider the refusal in Putrajaya, it is very low. The refusal in Putrajaya is very low. Similarly, in Kuala Lumpur, the refusal was less. In Kidda, the overall refusal was there for every year. High refusal was there for every year, but in the year of 2014, the refusal was high. Similarly, in Perak, the refusal was in 2013, it was high. Then 2014, it was little bit high from 13. Then in the next year, it was further somehow increased, but in 2016, it was maximum. It became maximum. Like, and then the sum is in Sabah, the starting from 2013, very less number. Then 2014 also less number, 2015 little bit high, then 2016 was quite high as compared to the other years. So this is the simple way we can present the data into the bar graph. The data in the one table itself, we have presented this all. But if we want to explain the same into the statements, into the paragraph, then you just imagine how many lines we have to write, how many paragraphs we have to write. Maybe we have to write one by one, in one state first, then second state, third state, fourth, fifth, seventh, eighth, something like that. So all the states have to give the heading and then write few of the details. That can be difficult, but and simply giving this table is a self-explanatory, and we can measure, we can see the difference into the state level from one state to another state. If we want to compare Kidda with Putrajaya, we can easily compare. If we want to compare Penang with Kidda, also can be compared. If we want to compare Penang with the Sabah, we can easily see from the table and compare. If we want to see the Terengganu from here, easily we can compare with the Nigari Sambilan, So all the state can be easily compared from the table, so from the graph. So graph, the better way is we can compare, we can see everything on the one page itself. All the details are there into the one page itself. Then go to the pie chart. Pie chart is actually only can present data into n percentage. Percentage only can be given. The example is medical expenses of a country. Hospital, if we consider the hospital medical expense is quite high, 39.8. If we consider the dental services is 6.6. The least one is research is 3.3. Then medicine consumption, 14% of the overall medical expense. Then medical services, the expenditure is 18.3%. By this way, also easy is also easy, further easy, but maybe that much detail is not there. The example is like in hospital, how many are belongs to the which services of hospital, which the further categorization where the expenditure was in hospital. This detail is not there, but still the detail is there. We can easily compare that which medical expense use a maximum amount, which medical expense use a less amount. The research is using minimum, but the hospital is using maximum. Similarly, for medical expense is 18.3%, and then it goes to medicine, then 14%, something like that. So in this one also easy, the benefit is there. We can present one simple pie chart. One simple pie chart is there. From that pie chart, all the things are self-explanatory. But if we want to explain, then one by one we need to give heading. First heading can be hospital expenditure, then the other expenditure, research expenditure, community health expenditure, dental services expenditure, medicine expenditure, medical services expenditure. So all expenditure can be further need to discuss and tell in the line. It will be quite difficult for us to do that, but in the simple way of pie presentation, we can get the best way is the simple way we can present the data into the pie chart. Then the diagram example. Diagram is simple. We can make a research cycle. So first of all, it was started from here. We actually plan our research. Then we want to find the funds. Then we go for further development of this funds, and then we can get the idea to further improve, then read, then publish, then process, something like that. Or maybe we can say that it start from here. It was started here, like idea, then develop the idea, funding, plan, record, process. So it can be presented like this, or it can be given into the, you have seen that in your few days ago you were presenting your presentations. In that presentation, you have some of the students, they have shown actually their study flow chart. Study flow chart was there. So how many total number of participants was there in the starting? Let's say in the starting itself there was around 400 people was given the consent. Then when we consider the sample size calculation and then exclusion including criteria, from 400 there was decrease, then it became 320. Then from 320 further the dropout was there. Some of the patient, after giving consent, they drop out from the study. Then again the sample size became 280 or something, then again 180 something. It was like that. So all in your previous presentations, and that day when you were presenting your articles, in the presentation you have already presented the thing that is called as the best examples of diagrams. Diagrams can be flow chart of the study flow chart. First what we do first, then the second what we do, the third what we do, fourth what we do is, then it is called as the study flow chart. Maybe from here also we can put it at arrows we can add, then further explanation not needed. And similarly in your studies, when you present the data to us, in that study you have presented that how many total participants was involved, then how many dropped out, how many was left the study, how many was dropped due to different reasons, then finally how many was there. So if we want to explain into the words, then many words have to write, many sentences have to frame over there, many maybe the paragraphs has to comprise over there. But if we present the simple chart, flow chart of the study, it is easy for us. So diagram, the best example is the flow chart of the study. Then the data synthesis. Data, we can synthesize the data from different methods. We can synthesize the data. Data can be from the questions. Data can be through research. Data can be from a systematic review. The systematic review, how many studies was there, well formulated questions, how many through the research, so study selection of the study, critical assessment of methodology. This is all about the review article. But data, we can synthesis the data, we can generate the data. Like first we can create the Google form, we can send the link to the respondent can fill the data into the Google form, we will get the data. First thing. Second thing is we can distribute the questionnaire one by one to the participant. Then when we can collect back the response, then we can compile all the response together and make one research findings that is considered as one of the data. The other thing is we can, in the laboratory, if we are doing analysis in the laboratory, we can find out everyday findings, we can record in one page, that is considered as our data. In systematic review is a pure form of data. Mean that in one systematic review, you maybe you have seen that in one of the study there was total 90 studies was involved. So mean that all the 90 studies data they have compiled into one study. They make it one study from all 90 studies. Mean that, for example, we are saying that the effect of pharmacist was studied in Malaysia. How the effect of pharmacist was studied in Malaysia on diabetes mellitus. Okay, maybe we can say that in 2010 one study was conducted, then 2015 another study was conducted, 2018 another study was conducted. So these all studies personally conducted one by one. Then we compile them together and make one study all together. So mean that all the previous data we can compile it together, then make a meta-analysis, or we can make a comparison of intervention and control. We can do the comparison. Okay, let's say the intervention group is the pharmacist intervention, the control group is without pharmacist. The study was conducted in hospital Pulau Pinang, and total number of participants in under the pharmacist intervention was 30, and similarly for non-pharmacist group was also 30. The non-pharmacist group was going to the doctor directly, physician, and taking the medication going back. But the other group of patients, they are going to the pharmacist, then to the patient, then to the doctor, the physician. The physician has given the medication. Again, they come back to the pharmacist. Pharmacist tell them how to use the medicine, when to use the medicine, what are the lifestyle modification is needed for your disease, maybe asthma, maybe hypertension, what kind of food you should eat, what kind of food you should not eat, what kind of exercise is needed. If let's say a patient is having diabetes mellitus, so pharmacist will tell them further. At the end, when we compile the result, at the end we will see that the patient who are under the pharmacist intervention was having a better blood glucose level control as compared to the non-pharmacist group. Similarly, if we talk about the hypertension, the pharmacist group will be having better control of hypertension. The other group is not having a good control on hypertension. So this is one study. Similarly, maybe another study was conducted in GH Kuala Lumpur, another study was conducted into Prague state, another study was conducted into Kedah state. So these all studies was conducted in different places. When we compile their data together in one form, is considered as the systematic review. But when we put another further analysis on that, is considered meta-analysis. It means that in one study the group intervention group, the mean reduction difference from the control group was 0.5. Similarly, in Kedah state, the study conducted says that the difference was 2.1, something like that. So all the results compiled together, then we can say that a systematic review or meta-analysis was done in Malaysia, consists of 5 different studies together, and they prove that mean difference in a control group and intervention group is there. Thus, the patient who are under the pharmacist intervention, they are having a better control of disease as compared to the patient, those who are not under the pharmacist intervention. So mean that at the end, we can say that this all data, we compile it together. We compile the data together, make it one finding. Then this is all considered as a systematic review data. And with this, I think that's all from my side for today's lecture. By tomorrow, we will discuss further on it. Then thank you very much. If you have any question, you can ask. If no question, then thank you very much. And I think I have already given the slides to your class there. Once the system is stable, I will upload this lecture into your LMS portal. Thank you very much. If you have any question, you can ask. If no question, you may leave the class. You are free from my side. Thank you.